Okay. So do you have my slides?
You need your slides?
Well, it would help.
There you go.
There we go. All right. So hi.
Sorry about the technology.
Yes.
It's hard for you.
I know. Oh, hi. I'm Peter. I work for PowerDNS, and I'm also running here the dev room with Peter and the other folks. And I'm here to tell you a little bit about the new feature in PowerDNS Authoritative Server 4.2, where you can use Lua to generate answers. But not only that, because that's boring. We've been doing this in the recursor for all time. But you can even AXFR out this Lua to the other servers. So you have it all inside your zone, and I'm going to tell you all the cool things that you can do with it. So the big problem with DNS and DNS records in general is it's mostly static. People are trying to do some dynamic things like round robin, which sucks because then the resolver might have two addresses, but due to the cache will hand them out in a certain order for a certain amount of time. You cannot really do failovers. With SRV records and services that support it, you can of course have multiple servers and failover between them on a DNS level. However, HTTP does not do SRV, which is the service that is most used, of course. You cannot really have a more specific answer per requester, so there is eDNS client subnet that I'll discuss a little bit later as well that enables this. But by default, it's not in the DNS or within the zone. And there is no real way to do dynamic answers, or as Paul Vixie likes to call it, stupid DNS tricks. Even though they're stupid, we like them and they're kind of needed in the internet of today. So there are many solutions to these issues. There are alias records, there's CNAME flattening, there's flattening at the apex. We have a bunch of non-portable solutions as well. We have a GeoIP backend that you configure in YAML to do things. We have a remote backend that just calls a script where you can return records in any way, shape, or form. We have a pipe backend that does the same, but then as a sub-process. We have a Lua backend where you can type Lua and do all these things. And bind as GeoIP features in 9.10 and on, which is a little bit more of implemented as a view. And all these features, they're not compatible. If I want to do the same things in bind as I want to do in the PowerDNS GeoIP backend, I need a completely different configuration. And I also need to provide each server in my cluster with that configuration. There is no way for me to just use in-band AXFR to push this information to my slaves. So we would like to have something that can generate these answers dynamically, exists within the zone file, so there is no separate thing outside of the process, can be AXFR'd between different implementations, and preferably requires no changes in recursors, because you don't control those on the internet, so you should just ignore them at that point. So this is the solution we came up with, and they're called Lua records. And as we said before, we apologize to the Lua people, because Lua has to be spelled with one capital L and small UA. However, in DNS, everything is capitalized. So we call it Lua in full capitals. So what you see here is a small example zone. It has a Lua A record and a Lua Quad A record. And it already shows you some of the features that we've implemented. So if this server would get a query for example, for a.example, which we assume is the zone, it will execute this bit of Lua, which says if port up 443, so the HTTP port on one of these two IP addresses, it will return the address that is up, and if both are up, a random address is returned, or you can select, or you can have an extra option that will select which one should be returned. And the same goes for Quad A. Again, we check if the port is up or not. We check this, I think, every second from the name server, and if it's down, we mark it as down, and we do the redirection like that. And if you do short TTLs, that is very cool. So Lua records, they're actually very tiny Lua scripts that are embedded in the zone. The processing happens at runtime, so there is no pre-flight things that you need to do before provisioning these zones, you just put the Lua in there and it works. And we have a bunch of helper functions defined where for certain types, so like A, quad A, like if port up, that is a IP thing. For TXT, we have some log things. If you use GeoIP, we can actually send you the log record of where we think your resolver is. So, like I said, Lua, why this is a programming language? Why would we want this? So it's a very tiny language that you can embed everywhere. We have embedded it in DNS dist, it's in a recursor, it's already in the authoritative server in the form of an AXFR filter, where you can actually filter records that you get from an inbound AXFR. And it is super tiny. There are no batteries included. With Python, you get a huge standard library, and it's quite big, which it's good. But with Lua, you get almost nothing. You get a programming language, and there's no standard library. You can just make whatever you want, and it's super duper embeddable. So, like I said, we've already have it in the recursor and DNS dist. And it has many language bindings. You can run Lua in Go. You can run Lua in Python, because all these bindings just exist. We have a wrapper called Lua wrapper. It's for C++, and it allows you to just wrap C++ functions directly to Lua functions. And we're very, very happy with it, which makes it super easy for us to actually just implement this in a sane way. So how do they look like, those Lua records in action? So we have a couple of variables that you get every time a script is invoked. That is who, ECS who, and best who. Well, the names already say it. So who is the client IP address that you get. I'm not 100% sure about the interaction we have with XPF, but I'm pretty sure we will give you the... I hear Bert grumbling a bit, but we'll have to check that. So who will tell you the client IP address. ECS who, if you have EDNS client subnet enabled and you get an EDNS client subnet option, that ECS who will be filled with that address. And best who will be ECS who when it exists or who otherwise. So if you always use best who, you always have an answer there. And then we have a couple of functions that we have to create address records. So we have pick random. You just supply it with a list of IP addresses and it will just randomly hand out one. Pick W random. It will hand out a random IP address from a list, but that list is weighted. So you can have, I will have examples later on as well. So you can have a record with a weight of 20 and one with a weight of 10, and we will return the records with a weight of 20 twice as often as the one with 10. There's pick W hashed, which is again a weighted system, but we use the hash of the client to determine which address we're going to send. So we're not picking a random one, we'll always send the same answer to the same client. And we have pick closest. If you're using the GeoIP module, we will actually send the address that GeoIP considers the closest for this user.
Is this closest the feature of PowerDNS or of GeoIP?
We ask GeoIP, so we supply GeoIP with the IP information. We get an answer and we interpret that and then send off the response. So it's the interaction between it. But the information comes from GeoIP. There's some other functions. There is the view, which I found to be actually pretty powerful because you can implement views based on the source address, as bind can do this in the configuration. However, you now have it in your zone, so you can just distribute this out to your slaves. And you have lat long. This returns to GeoIP latitude longitude if we have it. So how would you configure this? This is actually a working PDNS.conf. You just, you bind to a few ports. You turn on EDNS subnet processing. You enable Lua records. They're disabled by default in 4.2. For one, they're experimental, and two, there are some security concerns, what I'll get to later as well. And in this case, I'm running everything from a bind backend because writing zone files is easy and it's easy to show you. However, Lua records can live within PowerDNS in any backend because they're just records. So namedu.conf, I have example.nl, I have two reverse zones that I'll show some things for as well. So this is the whole zone. Just put it here, so if you get the slide, you can just copy paste it out and it'll work. So for example.nl, I created a Lua A record with pick random with a couple of addresses. And so I wanted to give a live demo, but I don't really like the demo gods. And then FOSDEM came, yeah, you need an HDMI connector, and I don't have HDMI on my laptop. So I was like, well, then I'll just do the slideware. You're just gonna have to believe me, and use the configuration to do it yourself. So as you can see, pick random. I have a list of 3 addresses, and every time I run a dig against the name server, I get a random answer. Super easy. You can also do things with if you don't use the functions immediately in your configuration. You need to use a semicolon, as you see there, because we imply a return. So pick closest will return something, but you don't have to explicitly tell Lua to return it because we imply that. If you do a semicolon, we will not add a return, so you have to return yourself. So you can do if then else, or even way more code. So here you see another function. It's called netmask, and what it does, it takes best who and tests if it is in this netmask. If it is, well, it takes a true path. If it's not, it takes the false path. And as you can see from the dig as well, if I query it, so this is running on the local loopback. So if I query it, I get the false path, and if I add an EDNS client subnet option, which falls in that netmask, it will return the answer I wanted to return. But that's of course ugly. This is why we implemented view. So with view, it's very similar. As you can see, no semicolon because this has to return. I have 3 subnets. One of them is the fallback, and then based, and it will return actually a CNAME because, as you can see, it is service 2 Lua CNAME. And based on this subnet, it will return a different CNAME for the name service 2. So if I just send a normal dig, you see it takes the default path because there's no client subnet information attached. For the system 2, you can combine all these Lua records. So I have a if port up there, and I will also use the GUIP functionality pick closest to pick the closest address to the user if the ports are up for both. As you can see, I am doing a query with a subnet. I will get the system2.example.nl CNAME, then I end up at 05 because apparently 05 was up. So in the demo I would actually show you the log of the server that said, hey, this one is up, this one is down when I take services in and out of production. And if I use a subnet that is not within that range, you indeed see again that you get the default. Similarly, for an A record in another, for the other view, for the other part of the view, you indeed see the other records that you get back. So this was an up-down. At this point, only this one was up, and at this point both were up. But unfortunately, it's not a real demo, so you have to believe me and try it yourself. So PTR, there are a bunch of drafts. I'm pretty sure they're all expired to automatically create reverse records in zones. So within bind you can use $generate if you want to have certain names generated. And there's also the bulk RR draft, which is something that you put a kind of template in your zone, and then it will generate the name for you. We have done this within Lua. We have a couple of functions where you can generate default host names for IPv4, IPv6 addresses, and the other way around. You can do a wildcard record for a create forward. So let me show you that as well. So I have this zone. I can create a reverse record, which takes all the octets that it gets from the DNS. And if I would put a star.host.example.nl in the example.nl zone with a create forward with this same syntax, it will generate a forward. It will generate the name. Sorry, it will generate the address for the same name. So you can have it both ways. So if I do a dig for something within the first, let's see, 10.5, yeah. So within the first wildcard, it returns the octets in the reverse order, so in the IP address order name. If I do a dig for the star.1, I'm using a different formatting option there, and it actually uses dashes. And if you use the %6 formatting option, we will put the hex value of the IP address in the name. Same goes for IPv6. Again, we just have a zone with a single wildcard record, which has create reverse 6 %33. It's 33 because 1 through 32 are all the different nibbles you can get from the name. So you can even flip them around in the answer, which would be quite interesting. So if I would dig for this IP address and I use %33, it will just take the address, replace all the colons with dashes, and append the host.example.nl to it. So on the security of these Lua records, like I said, at the moment it's very much experimental feature. There's no sandboxing. They can be enabled globally or per domain. If anybody has access to your master and can slave Lua records to you, and you have enabled Lua records, they can just run arbitrary code within the context of the authoritative server. So this is something you should keep in mind. You can write a Bitcoin miner in Lua, that's no problem. Although we have limited Lua records to 1,000 Lua instructions per call, which is still quite a lot, but will allow you to do many of the things that you want to do. And of course, they use many more CPU cycles than regular records. So you would prefer to keep the TTL a bit high to not overload your authoritative server at that point. The current state, so as I was writing all these slides, I was playing around with it, and the usage is quite rough. Error messages are not super good. Right now, if you need to use the GeoIP magic, you need to start the GeoIP backend. We'd like to take this out and just enable GeoIP from the server configuration without needing the GeoIP backend. There are no pre-flight checks. If you put Lua in there, you will only see an error once the record is retrieved. So there is no checking at the moment of whether or not your Lua is correct. But it works, and you can do a lot of fun experiments with it. And I think on lua.powerdns.org, looking at Bert, there's a website with some configuration.
PowerDNS.org. Go to PowerDNS.org and there's a link there.
Yes, where you can see all the latitude, longitude, and all other kinds of fun things. So what's next for this? Because this is interesting stuff, but what do we want to do with it? So we're going to release Authoritative Server 4.2.0 somewhere soon. Alpha 1 is out now. We expect this to be like a month. We want to get some operational experience with Lua records, see what works, see what doesn't work, see what if we can change the security model, etc. Then we can polish the implementation. And we would like to create a minimal set of useful things, and maybe specify a little bit of how Lua should work, and come up with a proper specification of a version 1 of Lua records, and hopefully put it out to the ITF or at least to other implementers, so we can have this whole thing interoperable and have dynamic record generation for everybody. And that's it. So if anybody has any questions.
Thank you. Klaus?
Thanks a lot for this cool feature. I'm a bit concerned of how does this if port up, for example, check works like in the background, because it has to be scheduled regularly. So
Yep.
How often is it done, and is it configurable, and what if it's? I'm a bit concerned. Is there can there be some scenarios where it will block my standard
No,
DNS
no,
responses?
it is
also?
running. The checking is running separately from the query processes. It runs separately. It checks every second. It is not configurable at the moment. We would like to make it configurable eventually. Something I didn't show, by the way, there's apart from if port up, there's also if URL up, where you can actually state a full URL. It will do a HTTP request, and it can even check if there's a certain string in the response to see if it is properly up or not.
And it will do it once a second.
Yes.
Oh, and what if this checks for some reason does not work, and somebody queries like this label which has the Lua record? Will it then get a serve fail or just?
It will get a serve fail if the Lua is incorrect. If the server is down, it depends on your backup selection there. So you can specify, okay, if everything is down, just send this IP address. But if it's up, then send this IP address. So you can actually redirect your users to a sorry page if you want. Like, sorry, it's broken at the moment, please try again later.
I'm not concerned if the website is broken, but maybe the Lua feature in PowerDNS is broken, so that at least, because now you're checking a website, but what is more stable, the website or the Lua check in PowerDNS?
And of course it is not Lua doing the check. That is just a bunch of C++ code running in the background.
Yeah, so the implementation PowerDNS must be more available, high available than the website itself. Otherwise, it doesn't make sense to put in this function PowerDNS.
Well, yes.
Except that you can easily run two name servers.
Exactly.
Yeah.
Unlike you cannot easily run two web servers that will not load balance themselves.
And also, we can serve fail on this, so then your recursor will actually pick the next authoritative at that point, who would hopefully not serve fail.
Yeah, if it's also PowerDNS with the same Lua record, it may have the same problem.
Well, maybe some of the other vendors in here can help then. Shane?
Just a quick question. Can you give different R codes for different values?
Not right now.
So you can't implement full views.
No.
Does it have TSIG support?
Well, we have T6 support on the AXFR end, but we don't have T6 support within the Lua records.
I see. Okay. Almost there.
Well, we accept.
So you're
pull
asking
requests.
if the Lua code can see if the query had a TSIG? I like that, but we don't
If you had
print
these
it,
two features, then you could replace bind views, which would be quite awesome.
which is not a goal.
But it would be quite awesome.
I'll ask a simple question. Have you tried dynamically updating Lua records?
I have not tried.
I'll tell you, the reason why I asked the question is that I used to work for a place that did stupid DNS tricks professionally. And, well, that's in policy now. But part of the problem was executing what Lua is doing. Part of it, though, was our customers keep wanting to change their Lua, what would be the Lua instructions. So we constantly might change the instructions. I'm curious about how quickly you could change it.
So from the view of the name server, it is just another record in the zone. Because Lua, so we squat a private code point for Lua. So it is just a different record in the zone, so it can be dynamically updated if your server is configured to allow this.
No, the people at home won't hear you.
So for stuff like the PTR records and other things, can you do dynamic DNSSEC as well?
Yes, everything is signed.
Sweet.
That comes out of it.
That was an easy question.
Everything is signed, although if you combine with AXFR, it becomes a tricky story.
Yes. Yes, then you still need the keys online on your slave because the answers are dynamically generated, but yes.
Have you done some benchmarking regarding the checks? Because when you say the checks are run every second, so if I have tons of Lua in there which is producing the checks.
So Lua is not producing the checks.
Yeah,
once the function is called, in the background we will just check it every second. And this state is available to the Lua. There is no checking at that point anymore.
True, but
for
it's
Lua.
going to produce load on,
yes.
on the
So the
system.
answer is no, we have not checked this. However, if your web server cannot handle one request a second, you have a problem.
True, but the question is, what's the upper limit, or what's the recommendation? How many Lua?
So, like I said, this is experimental. We like to polish it. We like to get experience. So if you want to measure this, then please do, because this is also good data for us.
Thank you.
Any other questions? Bert?
You wrote this.
That's not a... You don't have a question, you have a comment.
So actually my comment is more of a question. Can you tell me, Peter, does this stuff also support load balancing on autonomous subsystem number, countries and continents with an exciting syntax to make sure that if people are not served by a local server, they will automatically fail over to a remote cluster?
Yes.
Yes. Anybody else? Any vendors willing to commit to an implementation now? No? Oh, it's too bad.
Yeah.
Thank you.